And hello everyone, welcome to my channel. So this is the video is belongs to some diode series. Okay, diode playlist. So already in the last class we discussed about clampers and the clippers and rectifiers also. So from the last 7 videos I posted related with the diode solved problems. So in this video I am going to discuss about some important solved problem from rectifier based circuits. In the last class we discussed about clamper circuits, how we are going to calculate the phi tau, and then how we are going to calculate the based on the given data, compare the phi tau to half period of the applied signal and then sketch V naught. That already we discussed in the last class. So in this video we are going to discuss about rectifier circuits. So here I am going to discuss about full wave rectifier, like bridge rectifier. So everyone knows about working of the bridge rectifier. Here I am going to solve rectifier circuits from bridge rectifier concept. Okay, so this theory and all we will discuss later. Okay, so now in this video I am going to solve one small examples problem by using bridge rectifier circuits. So what they're given, the data is, the given data is like one input source, then transformer is given, then this is the coil. So another transformer also given. That means the secondary terminal also given like this. From this they connected one bridge rectifier. Already I told you this is a connection between, it is a connection for bridge rectifier. The connection is connecting between these two lines. This is also connected. Here I am going to connect 250 ohms resistor. Here this is also grounded. The input is belongs to 220 volt AC, 50 Hz frequency. The ratio of the input and output primary and secondary term is 10:1. So what they are going to ask? So the given data, based on the given data, we are going to find, the first one is called V average or DC voltage. The second one is efficiency. So they are asking efficiency. Then finally they are going to ask output frequency from the given circuits. Okay, from the given circuits. Now I am going to solve these given circuits. First, based on I am going to redraw the circuits again once again here. Like for our reference purpose, one source is given like a 220 volt and then 50 Hz signal. Then transformer is given like 10:1. So diode is already connected as a bridge rectifier. So here a resistance also given like a load resistance 250 ohms. The circuit is like this. Okay, the circuit is like this. So from this the transformer ratio also given 10:1. Okay, so what they are going to ask, V average and then frequency and then V naught, V average, frequency and V naught. From this I am going to solve to find what is the formula for V average. So from this we are going to write important formulas. So from that only what are the important parameters we need to solve, we came to know. So the first one is V average equal to V2Vm by pi is the first formula. The second formula is eta. The first one The second one is eta. Frequency equal to I square DC R by output current divided by input current. I squared RMS into R. So finally, for substitute this, we will get frequency value. Okay. So from this, we don't know what is the value of Vs. So from Vm, so here 2 Vm by 5. First I am going to solve V average equal to 2 Vm by pi. So what's the formula for Vm? What's the formula for Vm? We don't know about Vm also. So we know about another formula. We know that Vrms equal to Vm by root 2. Vm by root 2. So Vm by root 2. What is the value of Vrms? That means input voltage. So already given here 220 volt, but we don't know about this voltage. So this is called Vrms voltage. So but the voltage ratio also given 10:1. That means based on the number of turns, primary turns, input turns, and number of secondary turns and primary turns, like NIP and N over NP equal to 10:1. Finally, the 10 is like as 220 volt by 1, that 1 Vs. So Vs equal to, so already they given Vs equal to 10. So 220 volt by 10. So already they given the value 220 volt by 10. Finally we are going to get 22 volts. 22 volt. That means Vs or Va equal to 22 volt. So Vs and Va equal to 22 volt. From this 22 volt we can easily find Vm. So from this 22 volt we can easily find Vm. Vm equal to 22 volt multiplied times root 2. So finally 31.11 voltage Vm. So already we came to know, so we solved the data Vm. Just if we substitute the formula, V average equal to 13.11 voltage over multiplied with 2 over 3.14. Finally, by solving this we are going to get 19.8 voltage. That means V average equal to 19.8 voltage. Listen, so this is the formula. From this formula we don't know about Vm. So already we know the formula for Vm, 22 into root 2. That means Vrms equal to Vs into root 2. Va into root 2. We don't know about Vi. We are going to calculate based on the number of turns. Number of turns is given. So based on the number of turns we are going to calculate. Finally we identified the Vm value. Just to substitute the V average formula, we are going to get V average of given input circuits, given bridge rectifier input circuits. That means 19.8 voltage. Okay, so what is the peak inverse voltage? So already everyone knows peak inverse voltage equal to Vm. So the second value is, what is the peak inverse voltage? Peak inverse voltage is, it's also equal to, peak inverse voltage is equal to Vm. So already we know about the Vm value, 31.11 voltage. 31.11 voltage. So what is the value of eta? What is the value of eta? Like eta equal to P out divided by power in output by input. So output is formula is already we know that ID squared into R. So input is IRMS squared into R. So we know that ID squared into R equal to V squared DC by R over VRMS by R squared. So this RR should be cancelled. Finally we will get V squared DC and V squared RMS. So V squared DC into VRMS multiplied with 100, we will get the frequency value, eta value. So already we know that VD squared, already we know that VRMS. So VD squared equal to, so here I will write here V square DC equal to 19.81 voltage and V squared RMS equal to 22 22. So I am going to substitute here in the formula 19.18 whole square over 22 whole square. So finally substitute this with multiplied with 100. So finally we are going to get eta equal to 81.08 percentage of efficiency. Okay, eta equal to 81 percentage of efficiency. Frequency, that means efficiency. Then output voltage, that means output frequency. How much output frequency? Based on the waveform we are going to calculate output frequency. See here, so this is the input waveform, everyone knows. This is the input voltage, like F equal to everyone knows 1 by T. So here T equal to 1 by F. Okay, so I'm going to redraw this with the output, rectified output. From this I'm going to get, this is one output, this is another output, like T dash and then T dash, and then this is the value is T dash, and this value also call it as T dash. So finally this 2 value is call it as 2T dash. That means T equal to, the final T equal to 2dt dash. That means T dash equal to half over into T. So finally you know about the T dash. So T dash equal to, finally you substitute this value. So automatically you may get T dash equal to 2T dash. Finally the frequency formula is 1 over F in 2 terms of T dash. See the T dash. So T dash equal to 1 over F. So 1 over F. So finally F naught equal to output frequency equal to 2F in. So this is F naught 2F in. So what is the output free? What is the F naught? F naught equal to 50 hertz. So what is the F in? Sorry, F in equal to 50 hertz. So substitute this, we will get easily 2 into 50 hertz. We will get F naught equal to 100 hertz. So the given data as per our input circuits, peak inverse voltage is 31.8 and the output frequency is 81.8 and F naught equal to 100 hertz, and then another data is V average equal to 19.8 voltage. So this is a circuit, is belongs to bridge rectifier. The input voltage is given and 50 hertz is given. Instead of the secondary voltage they given number of turns. So we need to substitute the number of turns and reduce this value. We may get this 22 voltage. From this 22 voltage, just to substitute this 22 into root 2, we will get Vm. So substitute this Vm to this formula, V average equal to Vm by pi. Automatically we will get 19.8 voltage. So this is the voltage across that V average or VDC. After that we will get peak inverse voltage is equal to Vm, and then efficiency, finally output frequency. Thank you students. Thank you once again. We will see in the next video, but a suitable example with the different kind of the analog circuits. Thank you all. Thank you. We will see in the next update.